This is our introduction to exercise 2.1 on intersecting functions and 2.5 on literal equations. We're going to focus on the idea of intersecting functions. There we go. The whole idea of this, right, is to say that if we have two functions, what do they mean, right? And in order for them to meet, those two functions at some point x and y must equal the same thing. That's pretty much all that is. Okay. Now, obviously, with the straight line, let's say we have two linear equations. You're very familiar with that. It is only possible for three outcomes. One, which is at some stage they intersect once. Pretty straightforward. At some stage, or at no stage, let's say, it ever intersects. In this very specific situation, what would have to be a key fact about these two equations? Thank you very much. Same gradient and also different y-intercept. Pretty straightforward, yeah? The only other scenario is that it has an infinite number of solutions because it's just the same line. Right? If it's the multiple of the same line, whatever it is, same line, therefore you have infinite number of solutions. However, when you're drawing lines that are different, so for example, your functions, one is a linear equation, one's a quadratic equation, there are different scenarios. So for example, let's say I draw a linear equation and I draw a parabola. It is possible that you have two solutions. If we change that quadratic to a cubic, it is possible that you have three solutions. Yeah? So depending on how we get our answer. Now, for this, we're going to focus on having a algebraic approach to this. What happens if I provide you with a value of m or whatever it is, and I'm asking you to find, let me know what values of m for which these two equations don't intersect, or do intersect, or intersect once, or whatever it is, right? In which case, we have to refer to the quadratic formula. Just as a brief background, quadratic formula, which you should already know by now, this one right here, and you should already know that the discriminant comes from what's inside the square root of that quadratic formula. Again, it's a quick reminder. Our discriminant is therefore b squared minus 4ac. Right? You don't have to write everything down, just write down what you think you need to write down. B squared minus 4ac. Right? And it determines the number of roots for a quadratic equation. In basic terms, just means how many intercepts. B squared minus 4ac, because it's inside of a square root, if it's positive, the square root of positive could be plus or minus. We could have two values. If it's equal to 0, the square root of 0 is just 0. There is no other option. It is one answer. Therefore, you have one real root. They use the word real because we're focusing on the real plane. And of course, if the discriminant, b squared minus 4ac, is less than 0, right, because you can't have a square root of a negative number, it doesn't exist, we're fine, move on. Right? We have no intercepts. Let's look at this example here. It says find the value of m for which the graph of y equals mx minus 1 and y equals x squared plus 4x do not intersect. Am I speaking too quickly at all? Alex, am I talking too quickly? No? Lovely. Take a seat then. Thank you. So y equals mx minus 1 and y equals x squared plus 4x. The idea is if we're looking for where they intersect, now in this case it says do not intersect, but that's in the case where we're finding the value of m. Of course, intersection will just let them equal each other. So I have mx minus 1 equals to x squared plus 4x. I'm assuming I'm letting them intersect. Great, let's just rearrange it to give us our original generic form. So we get x squared plus 4x minus mx plus 1 equals 0. Just to make things a little bit more convenient for myself, I'm going to write x squared and factorize that, so it becomes 4 minus m x plus 1 equals 0. This is a question that VCAR absolutely loves to ask, so it's really important that we know how to solve a question like this. Using my discriminant, of course I know that my discriminant, in this case it says does not intersect. Does not intersect. So if it's not intersecting, my discriminant must be less than 0. So my discriminant, which is less than 0, is b squared, which in this case would be 4 minus m squared, minus 4 times by a, which in this case is 1, times by c, which in this case is still 1, and again that is less than 0. Expanding that, I get 16 minus 8m plus m squared minus 4, which is less than 0. Or simplifying that, we get m squared minus 8m, that is plus 12, is less than 0. Now the question is, how do we solve this? Right? M squared minus 8m plus 12. Have we done this last year, solving an inequality like this? Okay. The lack of movement says no, so let's get started. In this case, the first thing I'm going to do, right, I'm going to say, what if m squared minus 8m plus 12 equals 0? So let's say, let m squared minus 8m plus 12 equal 0. I know, you know what, I'm just going to rewrite that so it's more space. There we go. I know that I can factorize that equals to negative 6 and m minus 2. There we go. M minus 6, m minus 2. Any qualms? M equals to 6 or 2. I'm going to draw a very brief sketch, right? This sketch is just here to help me solve this question. If it's 2 and 6, I know my intersections are going to look something like this. Again, does not need to be perfect. It's a positive parabola. M squared is positive. So I'm just going to draw something like that. This is just to help me with understanding this. I know I'm looking for when m squared minus 8m plus 12 is less than 0. In order to get less than 0, it must be between these 2 points here. Therefore, m is an element of, and you can write in any notation you like, from 2 to 6. If I substitute any value from 2 to 6, not including 2 and 6, then when I substitute it, my two equations will not equate. There's no intersection between them. There doesn't need to be an intersection between a linear equation and a quadratic. For example, if it looks like that, there is no intersection. For any case where m is between 2 and 6, non-inclusive, then you get no intersection. Does this seem familiar, or is this something new? I do need to know this. It's familiar. Okay, thank you very much. Okay, any questions about that? Okay, to reiterate, first we find the discriminant, right? By equating the two equations, find the discriminant, and let's define it in this case where it does not intersect, where discriminant is less than 0. If you're asked to find, for example, where there is one intersection, of course you let it equal to 0, and you solve it as you normally would. Okay, I'll zoom out so you can see. There we go. So solving inequalities, right? On your calculator, you can do the same thing, right? If you want to solve an inequality, you can do the same thing by graphing it and just finding it, or you can just use the solve function on your calculator. So if you go, let's say in this case, the m squared. Oops. One moment, I'm going to fix this up to fixed size. I'll bring it to the larger size in a moment. So let's say, oops. Let's say I clear my calculator and I want to find the m squared minus 8m plus 12, right? For me, this is a personal thing. For me, I always just hit enter just to double check that what I'm putting with the calculator isn't being mistaken as m to the power of 2 minus 8m. Yeah? So I just hit enter. I'm happy with that. I'm just going to copy that down. Again, that's just so that I'm not feeling worried about where mistakes might happen. Less than 0. If you're not sure where the less than is, it's math 3 in your keyboard. And then you can just select all of it and solve. Now, I'm sure you solved last year. Again, just a personal thing. My recommendation is to always type out what you need, right? Type out what you need, and then solve. Don't go into the action. Don't go into interactive, sorry. Let me clear this. Don't go interactive, advanced, solve, and then type in your equation. It can get very messy very quickly. You'll make a mistake with brackets or whatever it is. So don't do that. Just select all what you need. Right? And then go interactive, advanced, solve. Of course, in this case, there's no solution because I need to define m, not x, and then it'll give us our answer. Okay? So again, don't type in your function into that window. Type it in normally, highlight it, and then press solve. You're far less likely to make mistakes. Alternatively, you can use the interactive equation inequality and solve, but it'll yield the same thing. Any questions off the back? Okay. I'm going to move on to literal equations, 2.5. Again, it's a very short exercise. It's pretty much just transposition, okay? So the idea of literal equations is that all we're doing is we're presenting with an equation where there are less numbers involved. There's no 5x equals 7, for example. It's just this pronumeral equals to another pronumeral. It's literally transposition. If you know your log laws, exponential laws, etc., this will be pretty straightforward. Later on, we do inverse functions. This skill is important, right? When we switch, for example, our logarithms and exponentials, it's important that we know how to transpose and follow the rules. When it says solve for x, solve doesn't necessarily mean give me a specific number, right? So all I'm going to do is rewrite the equation and transpose to get x by itself. So in this case, I'm going to plus c on both sides. So 5a 3x minus b equals to y plus c. Sorry for doing it in red. And then I'm going to divide both sides by 5. A equals to, sorry, not a to the power of 3x minus b equals to 5y plus 5c. And then I'm going to apply my log laws, right? Now the question is, do I do log base a now, or do I do it after I separate the powers? In this case, let's give it a go by just writing log base. So log base a of 5y plus 5c equals to 3x minus b. Now, without doing anything else, is it a straightforward response now to keep going, just get x by itself? Yeah, I could just add b and then divide by 3 on both sides, right? So x would equal to, and again, I'm going to add b, so log base a of 5y plus 5c plus b all over 3. Looking right 1/3, yeah.
Isn't it supposed to be y plus c over 5 instead of 5y plus 5c?
Sorry, say that one more time for me.
Is it supposed to be y plus c over 5?
Thank you very much. That is meant to be divided by 5 on both sides. I see why some of you are looking confused. Yes, that is meant to be 1/5 of y plus c. There we go. Thank you for picking that up, Jody. Yes. But again, all we're doing is rearranging to get x by itself.
What's log 2?
With this one right here?
Yeah.
A, log base a, yeah. Let's do the same thing but with a original log, which requires us to work with an exponential. So in this case, solve for x when y equals a log base e. I'm going to just go ahead and write e to the power of y equals to x minus a over b. Right? Again, we're just applying our log laws. I'm going to transpose it to get base of e to the power of this value on the other side of the equation, which is y. Multiply both sides by b, I get x minus a equals to e to the power of y minus b, sorry, b times, there we go. And then just add on both sides, x equals to b times by e to the power of y plus a, done. That's it. Pretty straightforward exercise, isn't it? Any questions? Okay.